Hello students, up to now we discussed about the BJT, the construction of BJT, how the working of the BJT. So last class we discussed about BJT can be configured into three types. Those are, this is the one thing, common emitter and common base, common configuration, because it has three terminals: emitter, base, collector. So we will discuss each and every configuration. The first configuration is common emitter configuration. So in this this configuration is frequently used configuration, very frequently used configuration, highly used configuration, because it has very much applications compared with the common base and the common character. Here any configuration intention is to, we have to give some input and we have to take some output. So if you look at here, this is the emitter, this is the base, this is the character. Here emitter is made with the n type semiconductor and base is made with the p type semiconductor, and it is frequently used configuration. That means it has very much applications compared with the remaining compared with the common base and the common character, right? So in this our intention is to, we have to give some input, some output. First we have to look at what is the input terminal. So this is the base emitter terminal, is the input terminal. What is the input current? Input current is the entering current from the base is the input current. Okay, so first what is the input? Input is here, input voltage is base emitter voltage and input current is the base current. Okay, next what is output terminal? Output terminal, we have to take the output from these points, collector and emitter. So that's why the output voltage is collector and emitter voltage, and output current is current from this point, collector. So that's why this is the collector. So first, any configuration, first we have to recognize what are the inputs and what are the outputs. Okay, so here the most important point is we have to give some bias. So for the input, we have to, input terminal is the base and output terminal is the collector. So we have to give the bias for the base terminal and bias for the collector terminal, right? Here, so this is the input is better to give some forward bias. So input is P, giving the forward bias means we are giving some supply from the positive side, and collector is N and we have to give the supply for the positive. So input is reverse biased and output is forward biased mode. Just keep that. Input is forward biased mode and output is reverse biased mode. So in this mode generally this mode is applicable for to operate the amplifier, to act as the amplifier. What is the amplifier? Amplifier is nothing but which converts small signal to higher magnitude signal. These six small and is the comparison of magnitude. These are the magnitudes. Okay, these are the magnitudes, right? So first we have to discuss what happened. We have to discuss about the input characteristics and we have to discuss about the output characteristics. First we have to look at the input characteristics. So these are the input characteristics. Input characteristics are between the VBE and IB. VBE means base emitter voltage and IB is the base current. Base current is in microamps generally and VBE in terms of volts. But in order to get the input characteristics, we have to fix the output voltage. We have to take the fixed points of the output voltage. That's why we have to take first three types of output voltages. These are nothing but the output voltages. First output voltage is VC equal to 1 volts. So for that, if you draw the curve between input voltage and input current is follows this curve. And for the second case, it take the 10 volts. The curve between input voltage and input current is the follow this, and input current is the follow this. So these are the curves we will get. So if still we are increasing, the current value is increases. Okay, the linear, generally the input voltage and input current characteristics are linear mode. Okay. Linear. What happened actually between these input and output characteristics means, so generally what is the reason by increasing the VCE, collector emitter voltage, by increasing the VCE, why the current value decreases means, so what happened by increasing output voltage, VCE, generally depletion region width increases, for which, so we have three things. This is the collector, and this is the base, and this is the emitter. Okay, this is the collector, this is the base, and this is the emitter. So whenever VCE increases, the positive, and this is the negative. VCE increases means what happened, this depletion region, this is the reverse bias. Generally initial depletion region is like this. So by increasing the VC, the depletion region width will be increases, and whenever a depletion region width increases, the charge carriers in this depletion region width increases. Due to this, base current will be decreases. The base current will be decreases. So that's why the curves are, whenever by increasing the VCE, automatically the curves will be decreases, because by applying the VCE means, what VCE means, what happened, it is nothing but VBC plus VB. VBC also increases. VBC increases means it's a reverse bias, and automatically current will be decreases. That's why these curves are follows like this. So these are the input characteristics. Generally these input characteristics are not affecting, but the most important characteristics are the output characteristics. Here look at the output characteristics. What is output? Output is the collector and emitter voltage, because here the configuration, look at the configuration, this is the output terminal, VCE is the output voltage, output terminal. Okay, and what is the output current? Output current is IC. Output current is IC. So I already told you that emitter is the common terminal, base is the input terminal, and collector is the output terminal. So that's why we will go for the using the IC is the output current in terms of milliamps. So, but in order to draw the curve between output voltage and output current, so we have to maintain the base currents. We have to maintain the base current. Base currents means input current. IB is the input current. So this is the input current. Okay. Initially, if you take the input current is 0, then the curve between the output voltage and output current is follows like this. And if the base current increases 10 microamperes, then slowly, slightly this curve will be increases. And by increasing the base current, the curve between the output voltage and output current is increases like this, increases like this. Here simply, here the simply we can told that by maintaining base current, by maintaining the IB, output characteristics must be drawn, otherwise it is not possible. Must be analyzed. That means output gas means VCE and the IC. These are the output characteristics. So by maintaining the input, we have to analyze the output characteristics. Okay. So these output characteristics can be categorized can be categorized into three regions. First region is the, you know that the first region is, we can take the active region. Three regions. First is the active region. So this region is, so this is the region, this is the active region. So once again I will draw this region. So this region is the active region generally. This region is the active region. These dotted lines are the complete active region. In this active region is most important region, and we have the second region, that is cutoff region or saturation region. Saturation region. Third region is there. That region is, this is the saturation region. Look at here. This region is the saturation region. Third region we have, the region is the cutoff region. Cutoff region. Okay, we have three regions. So one by one we have to analyze these three regions, then we will understand what happened. Okay, first we will discuss about the active region. First is the active region. So active region itself, very important region. Active region, very important region. This is the, here active region name itself, it is actively participated. That means it is worked as an amplifier in this region. What happened in this region? So generally, if you observe this region, if you increasing the IB value, what happened to IC value? This is the IB, these are the IC. For IB 10 microamperes, this is the IC value. For IB 20 microamperes, this is the IC value. For IB 30 microamperes, this is the IB value. So by increasing the first point, we have to observe in active region. The first point is by increasing IB, IC increases. That means by increasing the input current, output current increases. Second point, by increasing the output voltage, IC increases. So look at here. So for this curve, for example, VCE is this value, and by increasing this, it slightly increases. So observe here, this is the first point, this is the increases. This is the first point, and this is the increases. This is the first point, and this is the increases. So VCE also increases, right? Why it is increases means, by observing the curve, we will observe that, and Generally, what happen means by increasing the VCE means we can increase VCB plus VBE. How? Look at here. Look at the diagram. What is this? Voltage between collector and the voltage between means I can write like this: VBC, voltage between these 2 points, and combination of voltage between these 2 points. So here what happened? By increasing the VCE, VCB also increases, and region between the by increasing this depletion region between collector base junction increases. Collector base junction is also increases. Okay, the effective base width, due to that the effective base width is decreases. Effective base width decreases. Okay, and due to that recombination is reduces. Recombination means holes are combined with the electrons are combined with the recombination is reduces. So more number of electrons crosses the junction, due to that more electrons are crosses the junction. So that's why by increasing VCE, IC also increases. IC also increases. Okay, so this process will happen. So generally, but in the diagrammatical we can look at here. So this is, for example, assume that this is the collector, this is the base, and we have the emitter here. Emitter. So by increasing the VC, we are increasing the VCC. So VCE means we have base and emitter here, and generally this is the NPN, NPN. N means here more number of electrons are available and less number of holes are available. Here less number of holes are available, electrons are available. So by increasing the VCC means generally we have some depletion layer is between these 2 points is there. This is the depletion layer. So by increasing this, what happens? The depletion layer width again increases. Depletion layer width again increases, and the number of charge carriers will decreases. Then whenever the number of charge carriers is decreases, whenever we input bias, the recombination are decreases, and more number of electrons will flow into the collector region. Then automatically the current also increases, and we have some equations are available here. Those equations are the relation between input current and output current. We can write like this: relation between input and output current is like this. That is, the output current equal to beta times of input current. Beta times of input current. Okay, beta times of input current, and we have a particular, we have more number. The second region is the saturation region. What is the meaning of the saturation? Saturation means getting the more current or constant current. So in the saturation region, just the transistor acts as the on switch. Sometimes transistor will act as the on switch, sometimes transistor will act as a off switch. That means in this region, so generally the transistor looks like this. So we are discussing about the PNP, that's why PNP. Here the transistor is acts as on switch, that means transistor is looked like this. The switching is between always, current will flow from the emitter to and the collector. Okay, This is the current flow in this region. So here, when it is possible, look at here. So if you observe this diagram, the current will be increases. Current will be when it is increases, when the VCE, that means the output voltage, becomes almost approximately zero, then the current will be in the rise position. The current will be increases this rise position. This area, this rising area, will be known as the saturation region. So that's why look at here, when VCE output voltage is zero, the collector base, CB means the collector base, becomes forward biased. How it is forward biased? There is no VCE means there is no biasing for the collector and emitter base collector. That's why we are giving positive terminal here. Then automatically this will be forward biased and this will also be forward biased. There is no applying here, and automatically then both are forward biased. The current will be supplied from these two junctions to the collector. Here that is only when VCB and VBE are forward biased. So VCB one junction, VBE second junction are forward biased. Then BJT operated in switch saturation mode. Saturation mode means on switch. So these BJT will be accessed like this. That means current will be flow from the emitter to the collector terminal. But the direction will be always shown from like this. So this is the saturation region, second region of the BJT. And the third region is the cutoff region. That means the BJT will act as the half switch. BJT will be act as the half switch. In this region, base current must be 0. So in order to operate this, base current must be 0. Look at where is the base current. Generally base current will be fixed values to understand the characteristics. So look at it, base current must be 0, this position. So in this position, the curve between output voltage and output current is follows like this. This region is the very low current, but it has some current. So this region is called the cutoff region or the off switch. So look at here, for base current equal to 0, IC current have some current, but practically we assume that it is the 0. This region is the base region. So by using this, we can understand whenever the BJT in the mode of active mode or active region, it will be acts as the amplifier. And when the BJT operated in the saturation region, it will be acts as the on switch. That means it acts as a short circuit. In the third region, when the BJT acts in the cutoff region, it will be acts as the half switch. So one BJT can be operated as 3 applications. One application is the amplifier, second application is the on switch, third application is the half switch. So this is the importance of our BJT. Okay. So by operating the different types of regions, automatically the BJT can be applied for the different applications. Okay. So this is the characteristics of the BJT. So this is for common emitter BJT. Okay. I think all of you understand this concept. Thank you.